Whenever you think of the cardiovascular system, think of these three components: the heart, blood, and blood vessels. Let's look at the main functions of the cardiovascular system. 1. Transportation of oxygen, carbon dioxide, and nutrients. Oxygen is transported from the lungs through the heart to the muscles and organs, while carbon dioxide is transported from the muscles through the heart and into the lungs to be exhaled, because obviously carbon dioxide is a waste gas. Nutrients are transported from your food, so nutrients such as carbohydrates or proteins are digested in your food and transported to cells for energy, growth, and repair. Next is clotting of open wounds. Platelets in the blood help clot wounds to prevent excessive bleeding. Next, we have regulation of body temperature. Blood flow adjustments help to maintain a stable body temperature. When body temperature rises, vasodilation occurs near the skin to cool the body down. Meanwhile, when body temperature decreases, vasoconstriction occurs near the skin to preserve heat. Inside your chest right now, you have a strong heart that looks something like this. Let's go on a journey of how your blood moves through the heart. Let's say you've just taken a deep breath. Gaseous exchange happens at the lungs, and then the oxygen from the air is transported to your left atrium in your blood by the pulmonary vein. The blood has oxygen, so we call it oxygenated. That oxygenated blood then moves into your left ventricle through the bicuspid valve, as you can see here. Then the oxygenated blood is pumped out into the body through the aorta, where it passes through the semilunar valve, which you can see here. When the blood has gone around your body and the oxygen has been used, then it comes back to get more oxygen and to remove the carbon dioxide that it has picked up from your muscles. The blood is now deoxygenated at this point because it's now full of carbon dioxide. The deoxygenated blood travels into the right atrium through the vena cava. The deoxygenated blood then travels down into your right ventricle through your tricuspid valve before being pumped to the lungs through the pulmonary artery, and it also goes through the semilunar valve. Some key irregular things to notice here is that 1. Your left ventricle is much thicker than your right ventricle because the left ventricle has to pump blood with more force throughout your body. 2. The pulmonary vein is the only vein that carries oxygenated blood, while the pulmonary artery is the only artery that carries deoxygenated blood. Here's a mnemonic to help you remember the valves in the heart. LABRAT, left atrium bicuspid, right atrium tricuspid. There are 3 blood vessels you need to know: arteries, veins, and capillaries. Arteries carry oxygenated blood away from the heart. They have thick muscular walls to handle high pressure, but the only exception is the pulmonary artery, which we spoke about before, which carries deoxygenated blood instead. Veins carry blood towards the heart. Alongside their large internal diameter, they have thinner walls and valves inside them to prevent the backflow of blood. Capillaries, they are tiny vessels where gaseous exchange occurs. They have walls that are only 1 cell thick to allow substances to pass through them easily. So we've spoken about the role of vasoconstriction and vasodilation in regulating body temperature, right? These 2 actions are part of a mechanism called vascular shunting, which happens to redirect blood flow towards areas that need it most. So for example, when you are exercising, your muscles need blood flow the most. So blood vessels supplying blood to inactive areas like the stomach will vasoconstrict, while blood vessels supplying blood to active areas like your muscles in your arms or your legs will vasodilate to deliver more oxygen. It is therefore important that digestion of food is complete by the time you start exercising, so that this process of vascular shunting happens effectively. When you're at rest, the opposite happens. There's vasodilation at the stomach and vasoconstriction at the muscles. Did you know that your body is made up of around 5 liters of blood? And this blood is made up of red blood cells, white blood cells, platelets, and plasma. Red blood cells carry oxygen and remove carbon dioxide. White blood cells fight infections and maintain your immune system. Platelets help in clotting to prevent excessive bleeding, and plasma is just the liquid part that transports all the other components of the blood, and they also transport nutrients and waste products. Now let's move on to the respiratory system. The respiratory system is all about the lungs and the airways and air itself. The airways are split into bronchi and bronchioles. Finally, we have alveoli for gaseous exchange. The lungs are just two large organs allowing gas to move in and out of the body. Did you know that your right lung is bigger than your left? Bronchi and bronchioles are just air passages that lead to the lungs and subdivide into smaller and smaller airways. Alveoli are tiny air sacs where gas exchange occurs. They have a lot of capillarization and thin walls for gases to move through. The diaphragm is a muscle that contracts or flattens and relaxes or curves to change the pressure in the chest. These are some lung volume definitions you need to know. Lung volume, tidal volume, and vital capacity. When you exercise, muscles need more energy, so breathing rate becomes quicker and deeper because there is a greater demand for oxygen into the body and more carbon dioxide has to be sent out of the body. And on the other hand, when you are at rest, the opposite happens, so breathing rate becomes slower and shallower. Now, just like we did with the heart, let's go on a journey of how air moves through your body. It starts with an inhale. When you breathe in, the air that enters your body is made up of 78% nitrogen, 21% oxygen, and 0.04% carbon dioxide. The air travels through the bronchi and bronchioles into the alveoli. At the alveoli, only oxygen enters these capillaries. This happens by a process called diffusion. The way this works is that oxygen diffuses into capillaries because there is a higher pressure of oxygen in the alveoli than in the capillaries. Then, the capillaries carry this oxygen to the pulmonary vein and the whole cardiac cycle, which we previously spoke about, occurs. When the blood comes back to the lungs through capillaries, it is now full of carbon dioxide, which is a waste gas, so we must remove it from the body. There is a higher pressure of carbon dioxide in the capillaries than in the alveoli, so carbon dioxide diffuses into the alveoli. The CO2 is then exhaled out of the body. The air you exhale contains 4% CO2, 16% oxygen, and 78% nitrogen. Finally, it's important to remember that the cardiovascular and respiratory system always work together to facilitate physical activity and exercise, so you should be able to talk about them working together.